Like you said, my name's Brian Barrow. I work at Deepgram. We are a speech-to-text company. We provide audio transcription services through our API for your pre-recorded audio and also live streaming audio. And Deepgram's been kind enough to sponsor the event today, and we'll be providing the transcription for the subtitles on the YouTube videos whenever they get posted from this conference. So today, I want to talk about Deno. So first, what is Deno? Deno is one of the latest JavaScript runtimes. Like Node, it was built on top of the V8 engine, and it's actually also created by Ryan Dahl, who was the creator of Node.js. Instead of using C++ like Node did, it was instead built using Rust. So the big question, though, is why? Why do we need another JavaScript runtime? Isn't Node good enough? So Ryan Dahl, after creating Node and after seeing Node evolve over the years and the ecosystem being built around it, he had a few regrets that with how it ended up and the state that it's in. The first regret that he had was that to start out, promises were not included in Node. They do exist in Node today, so you can use them in Node, but they weren't there initially. So a lot of APIs that were built throughout the years were built on a less than ideal foundation. Because of this delayed support for async and await, it prevented that from being built into these APIs over the years. And it's hard to add that back in retroactively without breaking a lot of people's code. Another regret that he had was that when you write JavaScript for the front end versus the back end in Node, the experience can be different, right? Node doesn't support all of the same APIs that the browser would. So while technically they are the same language, the experience in developing for both parts of the stack can be different and can cause some confusion. One really big example of this is the WebSocket API. So I pulled this screenshot from the MDN website, which shows that the WebSocket API is supported by Deno as of version 1.4. They just released version 1.25, by the way. But it is not supported in Node. That doesn't mean you can't use WebSockets in Node. It's just a different spec. It doesn't follow the web spec. Another big difference is the fetch API. So Deno has supported this fetch API since version 1, whereas Node just barely started supporting it in their latest release. Deno is also secure by default. You have to specifically enable access to things when you're using Deno, whereas with Node, you have access to a lot of different system calls automatically, and that can introduce a lot of security concerns. So, for example, to enable access to things like your environment and network access, you pass in these flags when you run your code. So that means by default, your code does not have access to the environment, to the network, to your file system, or subprocesses, which is really helpful. You have to specifically add those permissions. That can be cumbersome to pass in all these flags as you're developing, though. So they do provide this allow all flag in order to kind of ease that development process, so you're not having to pass those in each time you run your code. These are also configurable. So with each flag, so in this case, you can see in this allow net, this is allowing your code to only make calls to github.com if you pass that in. So that way you know your code is only accessing specifically what you want it to access. So if you bring in a third-party library that maybe has some malicious code, it's not going to access things you don't want it to access without your permission, which is really nice. Dependency management in Deno is also really different. Ryan Dahl, his goal was to make it as similar to coding for the browser as possible. So when you write code for the front end, inside of your HTML, you pass in a link tag, and you pass in a URL or a path to the code, either to external code or a file path that you want to run on that page. And it works really similar in Deno. You import things directly from URLs. Whereas in Node, you have your dependencies listed inside of your package.json file, and they are downloaded into the Node modules folder. The package.json file in Node is also where you would specify the version, whereas with Deno, you can define the version directly in the URL. So for example, here we are importing the assert equals method from the Deno testing library, and we're specifying version 0.148. So we bring it in directly. You'll also notice that unlike Node, where they have this magic index.js file where you put your code that you want to export or import, in Deno you have to specify the file name and also the file extension. So this leads to a lot less ambiguity when coming into a new code base. You know exactly where code is being brought in from, and you can find that a lot easier. Also, as of this latest release 1.25, Deno they have started adding experimental NPM support, whereas before they were incompatible. They are starting to add that compatibility so that code you might have inside of an NPM package can be compatible inside of Deno as well. There are some limitations with that, but it is getting better every day and with every release. Also to note, ES modules are the only thing you can use in Deno. You cannot use CommonJS. Right here. So Deno also supports TypeScript out of the box. So a lot of teams and a lot of libraries these days are moving towards using TypeScript because it's so nice to have that type safety and to be more explicit when we're writing our code. One of my favorite things about Deno is the built-in tooling. I understand each developer has their own opinions, and a lot of people like that flexibility of bringing in the tools that you like to use. I personally like having a standard and a recommended path to use in the tools that I use, because I'm sure a lot of you have been on different teams where if you move from one team to another, they might be using a different set of tools. And it takes a little bit to get up to speed and to ramp up and to be able to understand exactly how to work with that code base. When everything is standardized, it's much easier to switch from team to team or company to company and get up to speed. And so that onboarding process for new developers is sped up, and it's a lot more helpful. So Deno also, it ships with the standard library. This standard library was influenced mostly by the standard library available in Go, if you're familiar with that. Deno originally, when Ryan Dahl started building it, he started building it with Go instead of Rust, but early on they found some issues with the garbage collection process in Go and the garbage collection process in JavaScript, and there's some conflicting things there. So they decided early on to transition to using Rust, but things like this standard library are remnants of that influence of Go. So a lot of these you'll be familiar with. They're really similar to the Node core modules. So you can do the same things in Node, but in Deno, each one of these is a separate library. It's separate from the main Deno library, so each one can be versioned and they can be released independently. So that way you're not waiting for a new release of the entire framework to use the new release of the tool. So let's take a look at some real-world Deno. So my first introduction to Deno was earlier this year. Like I said, I work at DeepGram, and we have an API that you can use to transcribe audio. We have SDKs that we provide for developers to be able to use our API more easily. And I wanted to understand, get a deeper understanding of that API. And so I decided to build another SDK from scratch, just to kind of understand the ins and outs. But I didn't want to learn another language. JavaScript's my primary language, and so I didn't want the added friction of learning a new language on top of learning the API. So I decided to build one in Deno and really just fell in love with using Deno. So here's the code that we use to get a live transcription inside of the Deno SDK. So you can see that it's just wrapping around a WebSocket, but the implementation of the WebSocket is just like it would be if you were writing this code inside of the browser. The API to use that WebSocket is the exact same. And if we compare that with the Node code, again, it's just wrapping around a WebSocket, but the implementation of that WebSocket is different. So you can see when you are writing code in Deno that there's not a lot of context switching between how do I write this on the front end versus how do I write things on the back end. It makes it a lot simpler. So when you are working with Deno, like I mentioned, we manage dependencies by importing with a URL. And that can be repetitive over time if you're using the same import across different files. And so there is a convention, it's not required, but there's a convention to maintain a central dependency file where you import all these and import them into this file and then export them directly from there. That will just make your code a lot cleaner over time and make maintaining it a little bit easier. That way, whenever you need to import it in another file, you can just import it from just that file, and you don't have a long list of import statements in each file that uses those. So Deno versus all the other things. I guess the big question is Deno faster than the other JS runtimes? Jack Harrington from the YouTube channel, The Blue Collar Coder, he did some benchmark testing using the different tools available, and this is what he found. So you can see that Deno came in quite a bit faster than Node and these other runtimes. You'll see Remix and Bun on there. There's been a lot of hype surrounding Bun lately and how fast it is, and that's great. The more competition inside of the JavaScript runtime area is better for us. We as developers will benefit from this as they are competing to be the best out there. So you can see that in some of these cases, Deno is almost double, if not more so, or twice as fast than these others. And they just released in this latest 1.25 release, they released a new experimental server API, which seems really promising. So far it's reported to be 4 times faster than Node.js, and it's even 3 times faster than the current Deno web server. So if you look at these numbers here and multiply that by 3, that's some pretty fast code. So I'm really excited about that, and I'm excited to see where things will take this. The Deno team has committed that they have promised that they will be the fastest runtime, and so they are constantly working towards that. Next, Deno Deploy. So the Deno library or the Deno framework, the runtime, is built by the Deno team, which is part of the Deno company. Deno Deploy is the consumer product put out by the Deno company. It's a distributed system that runs your JavaScript, TypeScript, and WebAssembly at the edge. So the code you deploy will be available to your user and will be served to them from the closest region to them. Currently, there's 34 regions supported, and it deploys in less than a second, which we'll see here in just a minute. It's really exciting. It's really fun to see how fast that is. I'm going to show some live stuff about how fast that really can be. So Deno Deploy is the product behind things like the Supabase and Netlify edge functions. So if you're familiar with those, Deno is what is powering those. And they chose that because of its speed and its availability across the world. So let's take a quick look at this example. So as part of the local Free Code Camp study group that I run, I was demoing some Deno to them, and we were building one of the projects from the Free Code Camp backend certification. One of those is a date microservice, right? And so it's just an API that you call, and it returns a date time object. I added this text property just to show this deploy. So initially I had this hello world, and then I went in and added some new code so it will now say hello Utah.js. So I merge the code. I go over to Deno Deploy. You can see I had previously updated it 4 minutes before that. And then after that, 3 seconds ago, if I go to the API, it's already there. It's already deployed on the edge 1 second after I hit the merge button. So that's incredibly fast and incredibly exciting. So I'm excited to see where this product takes us and where it can push JavaScript development in the future. Fresh. So let's talk about Fresh. So Fresh is a new framework put out by one of the core members of the Deno team. They call it a next generation web framework. And it's been built for speed, reliability, and simplicity, which is unlike all the other frameworks we have been using over the years, which are slow, unreliable, and complex. But in all seriousness, we have come a long way in the framework world. And Fresh is just one of the latest part of this new generation of frameworks, frameworks like Astro and Quick, that use the philosophy or the idea of island-based architecture and partial hydration of static pages. So why do we need another framework? The Deno team, they wanted a framework that fit into this Deno developer flow. They've put a lot of work into adding this tooling and all the standard library and the TypeScript out of the box. And so they wanted a framework that people can use to develop code on the front end, but still use this developer flow that Deno provides. And it just allows Deno developers a better experience when they're building websites. So some of the features of Fresh, like I mentioned, island-based client hydration, or partial hydration it might be called. So what this means is that if you have a static page, most of the page being rendered on the client is just HTML, and you might need a little bit of interactivity, so you have an island of JavaScript in this ocean of HTML. So you are only shipping the JavaScript you need, not using JavaScript to render all of the HTML. It's also just-in-time rendering, meaning that there is no build step in the process. Whenever the client makes the call to the API or to the server, it renders it and serves that up to the client. So there's no build step before deploying the code. The build step happens whenever the client makes the call to the server, but it's incredibly fast still. By default, there's no JavaScript shipped to the client using Fresh. You have to explicitly opt into it. So this makes for a better experience for users, because if all they need to see is a static page, you don't need an entire rendering engine to render all that HTML. You just need that HTML. And so this follows that. But you do have that ability to add that JavaScript. There's also no messy configuration to get up and running with Fresh. Because it is built on Deno, TypeScript is supported out of the box, which is really nice. And it is a true server-side rendered framework with progressive enhancement on the client. It also serves as both a templating and a routing framework, meaning you can use it to have like backend functions or API functions on it. So each route in Fresh, it has two main parts, right? It has a handler and a component. The handler is called for each request that the route receives, and it returns this response object. You can return anything inside this response, a string, JSON, HTML, whatever you need to. It's also passed a render function if you do want to render a JSX component. You can see here, this is a GET request. You can also add a POST request handler if you have some form handling that you need to add that you need to change in a specific way. Inside of the component, if you are rendering a component, you have, it's just rendering JSX, and you can see it is using Preact as that rendering, as that JavaScript library in order to render those. You can also, let's take a look, you can have both a handler and a component. Like I said, each route has to have at least one of these, but it can have both. So you can have this handler function and the rendering function, or the component function. But yeah, so let's take a closer look at a Fresh project that I built. We have here, I just built my blog using Fresh. And let's see, here, let me go over here, inspect this, go to my network tab, and refresh this. So if we click on the request being made and the response that we get back, you can see that this is just HTML being responded back, like it just responds with this HTML. I don't have any interactivity on my homepage for the blog. just HTML and CSS, nothing really special to it. But that's all that gets rendered. If we wanted to, I created this page to showcase that JavaScript. So I just added this counter function. So if we refresh this page, the counter initializes to 5. If we look at the response here, you can see inside of the HTML, we now have these script tags bringing in that JavaScript that is needed for that island of JavaScript. If we go further down, what the code is doing in Fresh is it traverses the DOM and will look for these comments, which are, like in this case, Fresh, and that has the name of the component, and then it has an index. So it says anything in this, between these two comments, the opening and closing comment, we have, that's where the interactivity is going to take place. And then down here we have some more script tags. So this one is bringing in the props. You can see which is just an array. I only have one component on here, so it's going to find that 0th position and add those props to that code. So you can see it's just starting at 5. And then down here, we import this revive function, which is that function that traverses the DOM and adds that interactivity and applies it to each component as needed. So you can see this is the ideal way if you have a static page that just needs a little bit of JavaScript. This is a much more ideal way to serve that to your client, and it will be a much better experience for the user. And not a lot of JavaScript needs to be brought down for that. I think it's a really exciting project. Obviously, if you are building a full-fledged app, you might want to use a more robust framework, but for serving static content, this is really good. And then also just to showcase this routing, I just added this. It comes with, when you start a new project, it comes with this joke endpoint that is just fetching from an array of jokes. So it's just a function, right? So in this case, it's not returning any component. It's just returning a string of text. But yeah, it's really exciting as far as everything coming from the Deno world. Deno Deploy and Fresh, all these things are super exciting. The new web server, I'm really excited about, and I can't wait to see where things go from here.